Hello, my name is Elliot Finney, and I chose to do my Chapter 3 presentation on an article I found that talks about some interesting news concerning the moon. So, you've heard a good bit about this in class, about the upcoming Artemis missions, during which NASA will first conduct an unmanned flight to and around the moon, then later in 2024, they plan to send a second manned flight to the same or very similar path around the moon, which will take humans to the furthest point we've ever been in space before. While this is definitely interesting, it's not the only news to surface about the moon lately. Earlier this year, in July, scientists discovered specific locations on the moon where it's always sweater weather, as the article says. As it reads, a team led by planetary scientists at UCLA has discovered shady locations within the pits on the moon that always hover around a comfortable 63 degrees Fahrenheit. This is important because since the moon doesn't have an atmosphere like Earth's, there's no protective layer to stabilize the temperature. The sun's infrared radiation, or heat, is a lot more intense because of this, making the surface of the moon about 260 degrees during the day and 280 degrees below zero at night. I'm using the terms day and night loosely, though, as one lunar day is equivalent to 15 Earth days, so basically half a month. This means that not only is the moon's surface either 260 degrees or negative 280 degrees, but also that it stays at these temperatures for 15 days at a time. The existence of the pits means that if we wanted to create base stations on the moon, we would need to fabricate some type of insulation that can withstand both sides of the spectrum perfectly. Now that we know this, it opens the possibility of placing future base stations in these pits and avoiding the problem entirely, allowing the scientists to focus on other problems more carefully instead, like growing food and filtering water. This discovery of these low-temperature pits was made possible by a doctoral student in planetary science at UCLA named Tyler Horvath. Horvath, shown here, was the processor of the images from the Diviner Lunar Radiometer Experiment, which is a series of instruments on NASA's Lunar Reconnaissance Orbiter, shown here on the right, that includes a thermal camera. It was through the use of these thermal images that he was able to discover the abnormally stable temperatures of these pits. And here are my citations.